today I'm going to talk about optical devices. Let's start. First, let's talk about the characteristic of light. So there are three types. First, absorption. Second, spontaneous emission. Third, stimulate emission. So let's talk about each type of light. First, it is absorption. The electron is located in a valence band, so or something lower energy level, and then if the light come to the device, so electron absorbs some light of external light, it will be jump up to the next energy level because it has some energy from external light. So it means the absorption jump to lower level to a higher level. So it means absorption. And then second, it is spontaneous emission. So it is different with that absorption. It is go lower than before. So first, it is located in higher energy level, so it has more energy than lower level, but that electron push out its energy to the outside, and then it jump to the lower energy level. So in this situation, it is because of the electron's lifetime. Electron has their own lifetime, so if the lifetime goes on, they will lose their ability. So if the lifetime is gone, this electron will expose their energy and then go to the lower energy level. So in this way, the light or thermal energy will be exposed too. So this is the second type of light characteristic. And lastly, it is stimulate emission. It is different with spontaneous emission because it is not because of electron lifetime. It is because of the external energy. So if electron gets some external energy from outside, they can lose their energy. So after losing their energy, they should go down to the lower energy level. So that stimulate emission means those things because of external energy. So optical device is to make optical device, characteristic of light is very important, I think. So also because it is operate with light, so it is very important of surface reflection. Absorb the light effectively is very important to optical device because they work with light. So first, it is surface reflection. It is important theory of optical device. First, we can talk about the reflection efficiency. It is FL over FLI, so it is the input and output efficiency. And then it is equal to N1 minus N2 over N1 plus N2 squared. So we can calculate the reflection coefficient from this equation. And then this is the transmission efficiency. reflection and transmission is very, very important to optical device because, as I said, because it works with light. So transmission efficiency can be obtained from this equation, 1 minus reflection coefficient, and then it is equal to n1 4 n1 multiply n2 minus over n1 plus n2. So we can calculate this equation to get transmission efficiency. And then also we should know about this equation. It is FLX equal FL0 exponential minus alpha x, and in this equation alpha means absorption coefficient. So absorption and reflection transmission is very important concept of optical device. So if the absorption coefficient is higher, that device can absorb the energy very well and effectively. So if we give small light, that device can change the energy light to electrical very well. So it means very effective device to use. So this absorption coefficient should be higher, and we should make effort to make more higher absorption coefficient. So it is very important concept. And then light in the point of view, in the p-n junction view, we can draw the p-n junction like this, and the middle of this part is the depletion region. So depletion region is very important reason because almost every electron hole pair will be generate in this region. So if we get more bigger depletion width, we can make more electron hole pair and generation. So it means we can make more electrical energy than before. So we should make an effort to make a bigger depletion width. So and this part and in this p-n junction, in the depletion region, the electron and hole will move by electric field. However, in the neutral region, the electron and hole will move by diffusion. So in p-n junction, it has internal electric field. So we should use the internal electric field very well and move the electron and hole very effectively. And then we can talk about the field factor. Field factor is the maximize the device efficiency. So actually the short circuit current and VOC, multiply the VOC means the maximum field factor, but however the real world, the IV curve will draw like this blue line. So actually the real field factor will be happened in this IM and VM. So we can the probability or proportion about the maximize field factor and real field factor. So this is the calculation equation of field factors. So ISC, short circuit current, multiply VOC, IM multiply VM over short circuit current multiply VOC means field factor. So field factor is this equation can be used to calculate the efficiency of device. So we can know about this equation. Because short circuit current multiply VOC means the ideally field factor, so it cannot exist in the real world. So actually the field factor typically on the order of 0.7. So actually we can obtain the field factor like 0.7. So, and then we can talk about the diffusion length. Diffusion length is also very important parameter, or something to efficiency, because if we make more bigger or longer diffusion length, it can develop the efficiency. So we should make an effort to make a longer diffusion length. And actually, if the material volume is bigger, the short circuit current will be also get higher. So in this reason, before the diffusion length, it is linearly go higher, but after diffusion length, the current will maximize. So diffusion length is very important concept. So we should make an effort to get more longer diffusion lengths. So today we talk about the optical devices and the basic concepts. So thank you for watching my video. Bye.